All right. Good morning, everybody. This is Uncle D with the Lean Guys podcast. With us today is a very special guest. One of, I know, is a mentor for me and certainly for Johnny Dubois. Mike Floyd. Welcome, Mike. How you doing, buddy?
Greetings. Good to see you guys.
Good.
Doing well.
Say there's a third lean guy that's missing today, but we'll get him on the next time you're on the show. Would you do a favor for our listeners? Would you introduce yourself? Let everybody know a little bit more about who you are, what you did in your career, and maybe how you came to know John and I.
Oh, yeah, excellent. I was a Navy veteran. I got out. I went to school at University of New Mexico, got a degree in mechanical engineering. I came out, worked for Motorola, straight out of school. At that time, it was interesting. I went into the quality organization. A couple years later, I transitioned into the engineering organization for the next 5 or 6 years, and then got a real enamoring for the manufacturing side of the fence, basically advanced manufacturing. And all this was in the space business. So this is all for satellite equipment, satellite radios, those types of things. And so after about 10, 15 years, I pretty much had a part and played in most of the life cycle elements of a program. I was very interested to see how those transpired over time. So I eventually became a director, away now from the projects themselves and overseeing large departments. I oversaw as an engineering director, as a manufacturing director. In that process, you see the big picture. You see programs going south. You see lots of money. I mean, these programs I'm talking are typically $200 to $300 million a piece. Their life cycle's typically 3 to 5 years before delivery, type of thing. Half of it's classified, the other half's not, that type of thing. So very serious business, very big national security implications to the outcome. Like I said, lots of dollars, lots and lots of customer oversight, tons and tons of regulations and rules. I mean,
Right.
Just completely complex business, yet you look back and you go, we're not going to make it at this pace we're on and with the problems we're having. And some of this is launch dependent, and the last thing you ever want to do as a company is be the reason that they had to move a launch, because those windows don't come along very often.
Right.
So it was in those capacities, and in the process I was going through some concurrent engineering master's work with the Arizona State University. I wrote a nice big thesis with a couple of the professors there on concurrent engineering. Started seeing the power of concurrent engineering, ran a couple programs that way. But when you're in trouble, you're the director at the big high level, you say, I've got to bring in external help. It's obvious, even with our continuous improvement body within the company, we're not solving these problems, and we got some big cliffs in front of us, and we don't want to fall off them. So through the process.
Is that a nice way of saying I need a sacrificial lamb because it's too hot to do it internal?
Yeah, I've heard you guys use that term. It is. I hear you guys use that term. I think anyone watching this that's part of a big company knows, hey, I'm not going to fall on my sword on this.
Right.
And I'm not going to tell the emperor he has no clothes when he's the one that sets my promotions and my salaries and my bonuses, right?
That's correct.
You got all these boundaries instead. Now, let me flip it around, though. So then if you bring in an external source that can't relate and can't assimilate, and I got to just bounce off the site, because when I brought you guys in, I used to comment to you guys, it's a matter of hours. You're speaking the lingo. And I'm looking at you going, how the hell did you know the name, and well, the one guy said it an hour ago, and I'm playing it back, and when he said it, I noticed everybody's eyes went like that. So I'm going to use that vocabulary in the process here. And it wasn't by noon that everyone thought you're working there. They're like, what part of the company did he come from, and where do we get these guys? I'm like, no, they don't work for our company.
I used to turn my visitor badge backwards so that you couldn't see the red piece.
Yeah.
I mean, I knew I needed for my ITAR, and it stayed with somebody and all that, but it was interesting for me to see, that part of lean. For me, it was like 5S and cell flow and plant layouts and stuff. And all of a sudden, this is at a program level.
Yeah, it was a whole different level than what we were normally tackling.
Right.
And it brought its own challenges, but it brought its own fun and reward too. I mean, those were fun Very intense, but fun projects.
In the end, they're a blast. You're right, but you've got that tipping point where you're like, and you guys used to say we got about 3 hours to know whether we're going to come out of this alive or not.
Right,
By the
right.
way, now I remember where I met you, Johnny D, teaching us how to build a clock over there in
Right.
the manufacturing extension program.
That's right.
In that training.
I said, man, God, this guy's an arrogant son of a bitch, but looks like I'm going to learn something.
And the funniest part was, I think in like the third round or whatever, you made some kind of comment how you were calling in sick or going on strike, or I don't remember what it was, but you were just going to be a disruptor. And so I just looked at you and said, hey, that's fine. If the system's built right, it should absorb the problem. And we just kept right on rolling. And you're like, holy crap.
Yeah.
I was impressed. I was impressed.
Well, Mike, when you have nothing to lose, you just go for it, right? I mean, for us, I mean, it was like, well, listen, we usually work with small to medium-sized enterprises. We had done a bunch of work with the shipyards. We weren't afraid of big program work. Inside, I'm like, a satellite or a ship, it's not really my problem. It's the engineer's problem. It's not, but like you mentioned before, working all ends of the life cycle was something that I really find I can reflect back on now in my career as something that was a huge experience.
Mm-hmm.
When we were first brought in, it was like, we need to save a year off of a 3-year problem. But then over time, we had the opportunity to work when it was zeros and ones before it was even, a full concept, right?
Right. And if I'm imagining a lot of people that can say they've had this whole life cycle picture. If you really have, you really do understand the value of those early phases. And
Right.
I wrote a word down today. I said, or 2 words. I said the biggest problem there is lack of patience in those early phases. You're not cutting any metal. You're not making any noise. You're not bringing in people that are, quote, going to make us something that a truck can pull up and drive away and then we get our check. So what are you doing? And what do you mean you've got multiple options in front of you as far as your design solution, right? And we ended up, and I've had this conversation in an international meeting across the board. I won't name who set it up. A good guy, I still respect him, but he set up an international telecom back in the day. And we talked about the effect of these early phases and the fact that the U.S. industries don't have the patience like you see in Japan, like you see in other countries. And so when I was doing the master's work with ASU, we studied Japan quite frequently. They have a process, for example, where they'll have multiple design teams kicked off for months, and they'll say, here's the deal. Here's what our ultimate goal is. You 3 teams go off and work this, and we're going to have a kind of a design off in 3 or 4 months. And they would be 3 totally different solutions. And then the irony, the culture was fine with that. I mean, there was patience, which team you're on, didn't matter, whatever you're doing it. It's an innovative environment, basically. At the end of the 3 or 4 months, they go through gates, not just dates. And I'll use that term coming up, gates, not dates. Give me a milestone I have to step over, not the fact that it's September 15th and we said we'd be done. So let's move to the next phase, right? And
Right.
it's really early. It's really easy to move to our next phases in the early stage. There's no product. The design's here. We're going to do some testing, and there's nobody pushing back. They all want to move forward. So that's another example of impatience. We just blow through it because the date hit and we're done designing. Let's move out. We'll pound the pipe, as we would say. So when these design teams in Japan would come together, they would find the optimum design. And I learned 2 important lessons from talking to one of the Japanese development engineers that we were working with. He said in Japan, they have 2 rules. The first rule is the odds that the first design that you come up with is the optimum one is 0. Okay. The second rule is the odds of finding the optimum design goes up drastically with the number of options considered. Okay. So think about anything in your life. Now, one program manager can certainly argue, listen, we don't have the money to sit there and just consider an infinite number of options here. This is, so, okay, fair enough. That's the outside boundary. But my argument back was, but we can't just settle with the first feasible and then pound the crap out of the pipe and hope that we get what we want out of the end of it.
That's
okay.
right.
Would you tell people what you mean by pounding the pipe?
A pound the pipe says, okay, you could look at, I've got so many cost charts on a, if I break out the cost, I have a life cycle cost of a $300 million program. It took 5 years. It's a Pareto. It's got these low bars on the left for about 4 months, 5 months. And then this massive spike of people. Okay, we're talking 40 people to 240 people over a 4-month period. What they all are doing between those two phases is, if everybody's coming in, the production people, the material people, the quality people, the this people, the that people, we're ready to get her done. Let's take this design element. And they all got hammers, and it's called pound the pipe. If you got a big old pipe and things aren't working, you just pound on it and it gets the flow going. So every time there's a problem, just go down there and pound on that section of the pipe. And then, so they all show up, 200 of them with hammers going, we're going to pound the pipe. We're going to get this thing done. So that's the scariest part of a program to me, because, you know, there's a lot of efficiencies and innovations that weren't considered, that weren't allowed, that were never.
You're in firefighting mode. You're not in planning and ideation mode.
Firefight is another word for pound the pipe.
Pound the pipe, yeah.
Again, let's look at the life cycle effect. Once you're in that stage and you ramp up with those people, you've set, by that time, about 70% of the true life cycle costs are set. You can't affect them. When I say set, that means you can't affect them.
Right.
The only way you can affect them is drag them back into that conceptual and optimizing phase of the program, and nobody is going to commit suicide and tell the customer, hey, we had a revelation and we decided we're going to redesign this thing.
Right.
You know?
Well, you know, when you get to the point of commercialization, if you haven't invested enough up front, and Johnny and I teach this all the time, your costs are going to go through the roof, and your break even and return on investment are just going to get pushed out, if not obliterated.
Yeah.
Right.
So the investment, we have a half dozen or so innovation projects going on right now through the Goodwill Southern California, and we're actually tracking. Johnny built this cost bogies tracking sheet that tracks the cost from concept inception to commercialization. And if you're under, you ain't gonna make it. And because if you haven't invested up front, when you go to commercialization, your costs go through the roof. Yeah. Right. You taught us well, Mike.
Okay, now wait a minute. I have a test for you then, because I've done the same thing, trying to prove the point. And that's why I go from gates, not dates. So Johnny, let me ask you, a gate there would say, hey, we can't proceed out of this phase because our life cycle costs are too high right now. We need to massage this more and look at more innovation before we can do it. So I'll ask you the question: have you lived that life cycle model in an environment where you failed that test but continued to proceed?
Yes.
Okay.
But the
thing to do.
What's that?
It's the hardest thing to do, is to stop it because you haven't met that gate. They go, how about a bigger hammer, and we'll get the big guy that can pound the pipe even harder. That's the answer.
Or worse yet, a marketing guy builds a flyer and starts selling it.
Shut up. I've read those flyers. I'm like, is that what we have on the factory floor now? Are you kidding me? Yes.
Also do the other half of that equation and tell you something else that we've done, where we have received, this is before I became a consultant, we had received the customer supplied design, and it was a product that we needed to build. And the first thing that we did after we won the business is make a list of all the minor changes that we wanted the customer to do to their design, and all the savings that they were going to get if they gave us those concessions, because it was easy for them to draw, but not easy for us to make.
Right.
And by the way, that customer was Toyota. So when we went back to Toyota and said, listen, we want you to make some slight design changes, one, they welcomed it wholeheartedly, which my management did not believe was ever going to happen. They thought, oh my God, this is suicide. We're going to go back to them. They've given us a design and we should make it. We've already won the business. Why are we going back to them after we won the business and ask them for these changes? So now here's the funniest part about that. Toyota said, keep the money, because we were going to give them cost savings too.
Oh, gotcha.
They said, hey, use that money to continually improve your process.
That's awesome.
Okay. That's, not to talk too general, but that kind of attitude, by the way, when you're done, your team comes back, they're incentivized to find more. They're
That's
incentivized to find, you know, it's the right thing. I'll tell you, another Japanese model, you got to lay them one over the top. It's the cost of change as you proceed down the life cycle. It's an
Right.
order of magnitude on every life cycle change you make. So if you're coming out of concept into pre-production, a change that cost $100 now costs $1,000. So John, you were in the mode where it cost $1,000.
Mhm.
And they said, fine, we should have caught it when it cost $100, but we'll pay the 1,000, right? Thank you. And they're thanking you.
Right.
Okay. And so then you get to pre-production and production. That's two more orders of magnitude. You're at, in my case, $100,000 to make a change. I'm talking a design change. By the time I'm in production in a space business with NASA and the other government entities on your lap, they're like, we've already certified it, we've already qualified it, and politically they won't even do it just for politics reasons, right? So anyway, the most astounding addition to that concept of cost increases, life cycles move, was you looked at the rate of change in a design in the Japanese world versus the rate of change in design in the US world, okay? Massive amounts of change in the early phases of the Japanese. We have the lowest. We had a nice little smooth, everything's happy. I'm coloring all the bubbles green. The customer's thrilled.
Right.
The this, the that. I had a wise engineer, systems engineer at the end of this process say, wait a minute. We win these programs and then we work our ass off to make the customer happy early. And we can see they dictate sometimes how we do development. They sign off on things they don't. They come back, they give us big bonuses because we're doing good, we're on schedule, we're all that. And we know in our hearts we're going to have a, because we followed their process, not ours, blah, blah, blah. I've heard it 100 times, right? This systems engineer, oh no, by the way, so if you look at, he drew a happiness curve, a customer happiness curve, peaking in the early phases, gets down to pre-production, it's kind of, I don't know. Behind schedule, losing money and all this. And he says, we end up shipping to the customer so pissed off that the happiness curve is way down here. And that's right when we want to win more business from
That's
them.
right. That's right.
Okay?
People are dissatisfied.
They're
Right.
dissatisfied. They're
Yeah.
like, I'll never go to that company again. That's just paraphrasing. But now let's flip it. He says what we should do is put our feet down, have the patience in those early phases, piss the customer off because we're not making the kind of progress they need, have them start unhappy. We've already won the job. They're not going to kill it. Well, he said, you got to get past the point where they can kill it. You got to get them to that point, but make them unhappy. About mid-level, they realize, oh, that wasn't so bad, and then pound the hell out of it and make it successful. And when you go to rebid that, you got them way up on the happiness curve. That was genius, he said, but we don't ever do it. Don't ever do it.
No, and that's one of the struggles that we have is if anyone hasn't done this before, sometimes we struggle with getting people to realize the importance of making those investments. And if you fail early in design, by the nature of experimentation, the experiment worked.
Yeah.
So
exactly.
What about, but some of those situations, Mike, I've been in, put in by you, where I'm working with a manufacturing team trying to get the supply chain and the production going on the plant floor. And then I realize, the design's not even complete. And we're buying stuff and we're putting it together. And it's like that design and build curve was so integrated that if it didn't fit, I mean, anything can fit on PowerPoint and AutoCAD, right? But when you start to do it, it's totally different.
Oh, okay. My quick story on an outboard unit up in Cape May, raining. They had a failure and they needed to replace it. The guy calls into the design team back in Scottsdale here and says, we need to replace that. And the three engineers say, okay, remove that unit and pull and put the new one in and put the 3 bolts in it. And he's like, there's not 3 bolt holes. No, if the unit we sent you has 3 holes, now just put the screw in the 1 hole and then it'll meet with the other hole. And the guys in the rain's pouring down and the customer's pissed because the system's down. And I'm sitting in the back and these engineers are like, do you have it done? And this guy he was on a big conference call with the customer and everything else. And he said, I'm going to say this as politely as possible, gentlemen. There is no frickin' hole. And if I hear it one more time, I'm going to get on a plane and come, I won't complete the sentence there. But I'm like, okay, so these engineers think they did it right. They're not listening to the guys that are doing it. And they never did, as your point, Dennis. They never really integrated early on. That's why you see the change curve in the U.S. so far down the life cycle.
Right.
And unfortunately, when those changes cost the most.